All right, line Y1, learning task 11, we're going to talk about split phase, which are going to be our single phase motor types of connections. And these are really going to be classified as one of two types of things. Either we're going to go and have a single voltage where we can only apply one voltage to that motor, you know, it's 120 volts, it's 240 volts, whatever it will be, or we're going to go and have dual voltage for these, which is going to be the more common one. We're also going to go through a whole pile of different types of connections that I can go and have. And of all of these connections, we're really going to go and focus, or at least I'm going to go and focus on the most common one, the field applicable one, which is going to be the one that has got the 3 windings inside of it. And we'll cover that one. I'll highlight that one when we get there, because a lot of these other connections that we see inside here, particularly where we're going to have split start windings, are going to be less commonly done. I've only ever actually run into one split winding, and I've dealt with a ton of motors. I did very little residential. I did mostly commercial and industrial. I've only dealt with one motor that had a split start winding as far as single phase motors go. And I've literally been into, you know, probably hundreds of them. So I would not stress out over, you know, when am I going to see this, when am I going to see that. We're going to go and focus on the one, and we will go and explain the other so we know what to do if we do actually run into them. But we are going to focus our attention on the one that actually is going to go and matter and that you're going to run into. Because single phase motors are going to be run into by most electricians. 3-phase, maybe your type of work that you're doing with the company that you're with, you might not run into them all the time, but single phase are going to be seen across all industries. All right, let's start by taking a look at single voltage motors. The very first one that they're going to go and identify is going to be my single voltage motors. Now, single voltage motors have got a junction inside them. We just don't see it. And what they do is they only bring out the ends of our leads. Every single phase motor is going to be a 4-winding motor, a divided winding motor. And what I mean by a divided winding motor is that I'm going to have my start winding and my run winding that are going to be divided up. So we're actually going to go and start with taking a look at a divided winding motor, and then we're going to come back and we're going to go and take a look at these single winding motors that are inside there. Let me start by just going and removing all of that, because we really don't need that, and then we're just going to go and ignore these ones over here right now. They're just other connections. And let's start by taking a look at this motor. Every single phase motor that is out there has got this for a configuration. We are going to go and have some windings that are going to go and be my run windings. We're going to have a few others that are going to go and be my start windings. That's going to be these ones over here. Those start windings that we see over there are going to go and have terminals that at one end are going to be a T8, and then we are going to have at the other far end a T5. And if I had polarity dots off of these, which they're not showing, but if I had polarity dots off of these, I would be able to go and put a polarity dot onto every single one of these, you know, showing that instantaneously they are getting the same values of voltage there. Now, what you need to know is that in a lot of cases, our manufacturers are not going to go and bring all the leads out of the motors. They're going to only give us as many leads as we might possibly need to go and have to go and operate that motor. So what they'll do is, in most cases, is they're going to go and make connections already inside of the motor. And usually the most common connection that they're going to make is they're going to go and make this connection between my T7 and my T6. And they're going to bury that deep inside of the windings of the motor. You don't need to touch it. You don't need to worry about having to go and touch it. So they're just going to go and leave that like that, which only leaves us then. Oh, let me just erase that there, because that's starting to get all weird. One more try. Here we go. There. Because all that it's going to leave us with is going to be this junction over here, the T8, and this junction over here, our T5. We don't need to access it. It doesn't mean that they don't exist. T7 does exist. T6 does exist. We just don't need to access them, and they have been tied together by our manufacturer. Some cases, they will do the same thing with my run windings, where they will go and say, look, it's just going to be a single value of voltage we're going to go and use for this one. So what we'll do is we will go and get rid of this T3 and 4. Instead of bringing them out to you, because they have to make different types of connections in order to do that, what we'll do is we'll just go and connect them on the inside. Once again, it does not mean that 2 and 3 don't exist. It just means that they've been connected inside of the motor, and they're only bringing out 1 and 4. So we're going to go back now to that single voltage motor. Now we're going to take a look at the single voltage motor, because the single voltage motor just means that they have made these connections internally. inside of here. If you take a look at this, you see T1 and 4, and what we just talked about means that there's a connection point that is going to be done somewhere inside of that motor, connecting 2 to 3. Same with my 5 and 8. I'm going to go and have another connection point that's going to be connecting 6 and 7 inside of that motor, but it's buried and I don't need to go and connect it. Do know that this is going to be your standard for your start winding. And do know as well that this one is the standard way that we are going to go in reverse rotation, is going to be to reverse our 5 and 8 for us to go and change direction of rotation on a single phase motor. Like all good pieces of electrical equipment, we are going to go and have NEMA standards that are going to go and apply to how these things are going to be connected. And which direction of rotation that we can go and expect, right? It's always good to know what's expected. You guys ask me of that, or ask that of me before every test. You know, what can I expect to have on it? I ask that of every motor before I go and connect it. Which direction can I expect it to turn? And is this going to be a problem for me? So I'm going to go and understand that this NEMA standard is going to give me a couple of, two main things that I'm going to know. Basically, if I have got the 4 to 5 connection over here, then I'm going to go and get counterclockwise. That 4 and 5 are connected onto the same line, and I see that over here. The 4 and 5 are connected onto line 2. I am going to go and get CCW, counterclockwise rotation out of it. If I go and change that and I make it 4 and 8 to the same line, then I'm going to go and get clockwise rotation. Do you guys want to know how I keep this memorized? Of course you want to know how, because I'm full of super cheesy memory tricks. My super cheesy memory trick for this one is clocks. Think about an analog clock. You might not own one. You probably just look at your phone all the time. But if you think about an actual analog clock, it is going to go and be the circular thing that has got numbers 1 through 12 going all the way around there, right? A clock moves in a clockwise manner. It has got 12 numbers on it, 1 through 12. If I go and add up 4 and 8, what do I get? 12. Does this have any bearing whatsoever onto your electrical career? Probably not, but it's a handy way to go and remember that if I take 4 plus 8 together, it equals 12. Therefore, I'm going in a clockwise manner. I use this one all the time, quite honestly, in the fields. Okay, this is going to be my standard setups that I'm going to have over here for a single voltage motor. What I need to understand about my motor as well is that each of my windings that I'm going to have brought out of the motor is going to be good for my value of line voltage. Meaning that if this thing is going to go and be a 240 volt rated motor, that would mean that this winding is good for 240 volts and this winding is good for 240 volts. And as a result, each of those individual lines is going to get connected across 240 volts. Look at this. I follow that one there, and I see that that one goes through. That's 240 volts line to line. And I would see that this one over here, I could go and see would be a line-to-line type of connection as well. Each of them is going to get the full value of voltage placed across. I just place them in parallel, and once again, go to that clockwise number 12, 4 and 8 that are going to go and add together. What we have more commonly is we are going to go and have split voltage motors. Now we're going to start by taking a look at this split voltage motor over here rather than this one over here. I'm just going to erase everything off of this one first, and then we'll talk about it, why we're not going to look at this one first and why we're going to look at the other one ahead of it. Yeah, just erase all of that stuff that I scribbled over top there when I was explaining how the windings are split up. We know every single motor is going to go and have windings 8 through 5 that may or may not be visible on the outside. You know, we might only have 5 and 8. Same as we know every motor is going to have 1 through 4, which again may or may not be internally spliced or externally spliced by us. We're going to talk about these ones here, which is going to be our standard divided winding on our run, but it's going to go and be a split one, or it's going to be a continuous winding 5 through 8 on my start one. First of all, these motors are going to go and have a rating 120, 240, the most common rating. You're going to see 115, 230, you might even see 110, 220, but these are all just other ways of us saying, 120, 240, which is our system that we operate under. If I take a look at the very first number, the lowest value of voltage over here, and first of all, we're going to identify this as being single phase because we see it as a low voltage ahead of a high voltage, right? If we go high-low, that's 3 phase. If we go low-high, that's single phase. So this is going to be 120 volts compared to 240 volts, which means that each individual winding is good for $120. Okay, $120 and $120 over here. Which means that if I want to go and connect it to the lower value of voltage, I would need to make sure that there's 120 volts across here, 120 volts across here, and 120 volts across here. So we see that in this first connection where I am going through, and I'm just going to highlight the lines, okay? I'm just going to make line 1 red over here, and I'm going to go and make line 2 blue. We'll make it blue, okay, off of here. So if I take a look, I see my line 2 is connected to T2. I see that line 2 is also connected over to T4. And I see that line 2 is also connected over to T5, like that. If I take a look at line 1 is connected over to T1. Line 1 is also connected over to T3. And it's also connected over to T8 over here. So we see that we have all of our individual lines that are going to be seen across here, right? Each one of these windings sees that full 120 volts, and I know that it is going to go and be counterclockwise because if I take a look, 4 and 8 are not connected to the same line, right? We can see that right over here. They're not connected to the same line, therefore we don't have a full clock. Clock shouldn't have anything other than 12. So this is going to be my lower voltage counterclockwise rotation. If I wanted to go to my higher voltage, what I'm going to need to do is I'm going to need to series 2 of mine together so I can go and drop the 240 volts across. Now, here's where the standard connection is going to be made, okay? We have to be very careful about the way that we go and put these connections together because in most cases, the manufacturer is going to go and take a look at the 2 windings and they're going to go and make some judgments about it. If you take a look at this, we know that this winding here is our run winding. Always going to be used. This one here is going to be my start winding, seldom used. Which one do you think that the manufacturer is going to go and overbuild? Well, you're a smart student. You know that the manufacturer is probably just going to say the one that gets run all the time probably should be the one that I'm going to go and overbuild. So when we are looking at doing our connections for these ones over here, what we are going to do is we are going to go and make sure that the one that carries the bulk of the current through to our auxiliary or to our start winding is going to be the most heavy duty one. Ultimately, what needs to happen is we need to go and drop voltage somewhere so that we can go and get to this value of 240 volts. And the way that we are going to do that is we are going to go and have seriesing up of my run windings, right? It just makes sense that if I'm going to go across my 240 volts, that I'm going to need to go and series up my run windings, and that way each of them is going to be able to drop 120 volts. And I'm also going to have to take my start winding and place my start winding across one of them. So it's also going to go and get that lower value of voltage over here. That's what we see down on this one over here. If I take a look at it, I'm going to just follow it through. We're going to go and give these actual numbers here on the side. I'm going to call this one T1. I'm going to go and call this end of that one 2. Then I'm going to call this end 3, and that's 4. Okay, that's my entire run winding was 1 through 4. This one over here is going to go and be my 5 to 8 winding that I'm going to go and have. And I am going to go and have my terminal 5, which is going to be my line out. This one here, which is going to be my 8, because once again, we're doing the counterclockwise one over here right now. If I take a look at this, I can follow this through from here. I see I'm going through line 1 through T1, come back up onto T2, and then at T2 I split, and I'm going to go and have some that's going to go down 3 to 4 and out, and some that is going to go 8 to 5 and travel its way back out there once again as well. So it's going to allow us to go and drop some of our voltage. We are going to go and drop voltage over top of a chunk of our start winding. Okay, we're not our start winding, our run winding. We don't want to do it over top of our start winding because the start winding, we know that inside of that start winding, if I were to series my start winding, let me just draw this out over here. It's insane. Take a look at it. If I were to series my start winding and then go and parallel my run winding, everything would be really, really good up until about 75% speed. And at 75% speed, remember, there is this centrifugal switch that is going to be inside of here. That centrifugal switch is going to go and pop open, and this motor is going to go and shut off. And so what you're going to get is you're going to get this constant acceleration where your motor is going to be click, 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 where it's going to be doing this like start thing again and again and again. This is why we don't series anything through my start winding, because the start winding in a lot of cases is switched and is going to go and kick out. We will go and change sometimes whether we are going to go through a 1 to 2 on our winding or whether we are going to go through 3 to 4. In other words, I can take what I have here and I can just move this winding up to the opposite side. If I move this winding up over here, just erase those over there, that is going to go, and now we've got that over there. Once again, I'm still going to have a continuous path through my run windings even after this thing goes and switches out, and it's still going to be seeing 120 volts that's going to be across it. This is the alternate connection. It is a less commonly done connection. Usually, it is going to be line 1 just comes in on T1, and then we series it through, and then after that, we go and split everything on the downstream side, the way that they show them over here. Connections as far as clockwise and counterclockwise, you should be able to see are going to be the same. The big difference between my clockwise and counterclockwise connection, and I'll just draw this one back down over here for my series, is just that I'm going to go and reverse the connection that I have over here. If I go 5 and 8 like that, 2 and 3 adds up to 5. It's a clockwise rotation. 4 plus 8 adds up to 12. That's my clockwise rotation. If I take a look at this, this is going to go and give me a clockwise rotation at my higher value of voltage. If I were to make the connection for the lower value of voltage, the lower value of voltage is going to be me placing these all into parallel, right? 1, 2, and then 3. Yeah, we connect them all up like that. This is my low voltage connection here. 1, 2, 3, 4, and then 5 and 8. And we're just looking to see if we got 4 and 8 together to give us number 12 off of that. It gives us our clockwise rotation at our lower value of voltage, and we can see that if we want to go to a higher value of voltage, we go to this with the 5 up here and the 8 up here. Okay, this one's the connection for that over there. This is your most standard connection, where we are going to go and have a split run winding. Very, very common for us to have a split run winding, but only have a single voltage start winding off of these. Okay? Just know that this is the motor connection that you are going to go and see. Are there other connections you could see? Absolutely. The alternate connection that we just explained over here is just really where we are going to go and take this winding over here, this one here, and we would just move it up so it's going across this, the 1 to 2 over here. So nothing new for us to go and learn there. This one over here is just going to be us now with a dual split, where it's going to be a split run and a split start. Once again, never ever probably going to go and see one of these unless you do a ton of work on, oddball pieces of equipment. This one is very, very uncommonly going to be found off of, anything. I've only seen one myself personally. So I wouldn't stress too much about this one. Just know that if it was going to be a parallel connection, or if it was going to be the low voltage, let's say I've got a 120, 240 rated motor, then if I want to hook it up to the low voltage, I basically need to put every single one of these into parallel. And if I want to hook it up to the higher value of voltage, what I'm going to do is I'm going to need to go and series them. So this is my low voltage connection. I'll just draw it out using the same colors as what we just did there before. Like that. And then I just connect these onto my lines that are going out. And I see that they're all going to be placed in parallel. I'm going to go and have 1s over here, 2s, 3s, 4s, and because this is for the counterclockwise one here, that means that the 8 side has to be on the opposite. So this would have to be my, I guess it doesn't have to be 8. We'll make this one the 8 and 7, and then 6 and 5 that we are going to go and have over here. Hopefully that goes and makes sense. It's all going to be placed in parallel across our 120 volt source. If we wanted to go to a series, or to the higher voltage, we would have to series those 120 coils. So we're going to go and have this one series, and then we are going to go and have this one series. What I should never do is I should never try to series one of my start or auxiliary windings with one of my run windings, because these ones are going to be switched out, right? So we don't want to have all of our main current running through them. Once again, 1, 2, 3, 4, and then this one here, 8, 7, 6, 5, like that is basically our connection we're seeing across here. Okay, don't expect to go and find anything that's going to go and have a split start winding. It is very, very rare to go and have that split start winding. Do expect, 100% expect, that you are going to go and get one of these. That is going to go and have a joined start winding, where 5 and 8 are going to have their internal connection already pre-made. Now, let's talk about reversing a single-phase motor. What do we do to go and reverse this motor? We always interchange the start winding. Why do we always interchange the start winding? Because if I would just interchange any winding, if I were to go and interchange this winding over here, right now, change around 1 and 2, which is one of my run windings, then what would actually happen is I would get net cancellation of 0 flux, and this thing would act as a short circuit. I'm going to go flip that winding, all of a sudden, boom, the motor goes and blows up, smokes out on you pretty much instantly. If I were to flip this one, I would get the same sort of thing. If I were to flip both of these together inside of this series, it would be fine. We would not have any issues. If I were to go and have the parallel connection, and I shouldn't have erased that one, but that's okay. It's only going to take a second to go and redraw it. Same deal would happen on my parallel one. If I were to go and take either one of my 2 run windings and flip them around, we would end up with a short circuit type of situation as well. No net cancellation of flux. So we would end up with our total net cancellation of flux. So we would end up with, once again, this short circuit where we're going to burn that motor out. Guaranteed, the 100% safest thing to do is to flip the start winding. It's 5 and 8, and it will always be terminals 5 and 8. So anytime you work with a single-phase motor going the wrong direction, 5 and 8. Flip it, 5 and 8. Okay, that's really all that we've got to talk about here on these connections. We're going to talk about oddball motors last.